We are Women in AI. We're a community-driven initiative, bringing empowerment to our community through different educational and networking events. We're also active on LinkedIn, so do follow us in there for some interesting reading, as well as knowing about our upcoming events. So today, in this session, in this WaiTUTORIal, we'll be having 30 minutes, around a 30 minutes presentation, and we're going to be learning about evaluating machine learning algorithms. So after the talk, we'll have a short session for some questions as well. So do keep them in the chat, or we can have a discussion later on. So thank you, Madhuri, for joining us and presenting for us today. So yeah, the floor is yours.
Thank you, Andrea, for a very warm welcome and a nice introduction. And today, first, let me talk about what are we going to discuss. Now, today, our main agenda is about understanding what are the evaluation matrix. So here we will see the evaluation matrix of classification algorithms. So now, when we talk about classification here, okay, so here classification is basically a supervised learning model, machine learning model, where you're trying to predict something. Okay, so when we say trying to predict something, it may be either a false or a positive. It may be a spam or a non-spam. It may be a cat image or a dog image, something like that. So what are we going to do today? What is the agenda of today's session? Today, we are trying to understand how can we compare different classification algorithms using various evaluation metrics. And today's session is going to be a hands-on experience. Okay, so it is going to be so much exciting to talk about and to understand how it is executed in Python and stuff. For today's session, what we are going to do is that we are going to take case study of two algorithms. One is logistic regression, and second is knife-based classifier. Of course, both are classification algorithm where we are trying to predict something. We are trying to predict to which class it will belong. Okay. Over as we move ahead, I will tell in detail how these algorithms work and stuff. But mind you guys, today's session is about understanding how can we compare and evaluate different machine learning algorithms. So let's get started. First, understand I have created a rough template where we have something pre-made, and then I will be executing something in front of you guys. So here, this is the template that I will be using for today's session. I have already imported two important packages. One is pandas and second is NumPy, one of the most important packages that we will be needing today. And of course, we have matplotlib, because we are trying to plot something. What we are trying to plot, that I will tell within some minutes. Now, let's first start by importing these packages. Okay, I'm going to use Jupyter Notebook, but the same thing will be working in Google Colab or any other Python notebooks. And then, now, first and foremost, let me import the data set, and then I will talk about what is the data set and what are we trying to do today. So first, here we are using PD. PD is nothing but an object of a pandas. And then we are trying to say read CSV. Why CSV? Because the file that we are going to use today is a CSV file. And what are we trying to do today? We have information about the customers, and we are trying to understand whether the customer will leave the bank or it will stay in the bank. So we are trying to understand what is the churn rate for the bank, how many customers will leave and how many customers will stay. And so for that, I have used this file, churn modeling. It has 10,000 records, and I will just show you what are the records in this. We have to perform classification algorithm. So for that, we need two things. One is X and Y. But X is nothing but something like we already know, and Y is something that we will predict, whether the customer will leave or the customer will stay. And that's nothing but Y here. Now, what are we going to do? If you see now, we have X and we have Y. Now, what is basically there in this X? In X, we are going to use from column like here, the geography, gender, credit score. The reason why we are mentioning here colon is because we do not want all these things. Row number, customer ID, surname, credit score, it's not going to give us any information. The most important variables that will help us to predict the output is nothing but your credit score, your geography, your gender, your age. From credit score, that's nothing but your column number 4, but the numbering starts from 3 till the last estimated salary. That's why we have mentioned -1, because we do not want the last column. And that's why we have your X. So X will have all the variables from geography till estimated salary. And then what is there in Y? In Y, we have only one column that is exceeded. So let me just run this one more time. And then let's see. Now here we are going to do some pre-processing. Okay, because pre-processing is not today's agenda, we will be just doing the pre-processing first because we have to focus more on the evaluation matrix. And then I'm just running. If you see here, I'm just running the X. Now, if you see here, what is there in this X? X has the credit score, geography, gender, age, tenure, till this estimated salary. So basically, it includes everything till the estimated salary, not the exceeded, because exceeded is stored in Y. So let's run the Y now. So this Y include the exceeded column, that is 1, 0, 1, 0 and stuff. Now, we have to pre-process some data because we cannot directly apply our classification algorithms on this. Now, what are the pre-processing part that we will discuss now? Now, if you see here, we have France, Spain, Germany. We have 3 country names which can be seen. Of course, it can be more because we have 10,000 records. But the thing that is visible right now is France, Spain, Germany. Now, we want our classification algorithm to consider it in a numerical format, not in a categorical format. So what we are going to do is that we are going to apply a label encoder over here. Okay, why are we going to do that label encoder? Because if you see here, we have France, Spain, Germany, and I want it in the label format, in the numerical format. So it will put it in the 0, 1, 2, because that will help us to apply the classification algorithm very nicely. Now, if you see here, we have imported label encoder from the pre-processing from sklearn. Okay, and then we have applied to 2. What does 2 stand here? This France, it indicates that we are going to apply this label encoder only on this column. That's nothing but your France, Spain, Germany. So let's just run this. Okay, and then I'll just display it here. So if you see here, okay, now, just sorry for that. Here it's female, male, it's been formatted into that. Why? Because we are applying label encoder here. And now one of the most important thing, now we are applying here one hot encoder. Now, what is that? I will tell you why we need this one hot encoder here. Now, why we basically need this, one of the most important thing that we have to understand here. Here, if you see, we have Berlin, Tokyo, Sydney. As I told you, we have France, Spain, and Germany. What we need to do, why we need this one hot encoding is because if you see here, we have Berlin, Tokyo, Sydney. What we are trying to do is that we are making it in a dummy columns. What does this dummy column mean? It means in the first row, we have Berlin. So for Berlin column, we will have 1. In the second row, we have Tokyo. So for the second row, we will have Sydney or everything else, the Tokyo as the 1. If you see Berlin is 0, Sydney is 0, York is 0. Why? Because we have Tokyo. So in that column, Tokyo will have 1. And now, if you see third row, what do we have? Sydney. So let's just find out in which column we have Sydney. We have column Sydney in this second column. So it will be placed 1. Now, next is nothing but your York, New York. Now, what will be happening here? We have to find out where is the York column. Here, it's in the fourth one here. So 1 will be placed in that 4. So why we are basically doing this one hot encoding is because we want this categorical variables into numerical formats. So that's why we are doing this one hot encoding. So after one hot encoding, let's say you have a column of countries, it will be something like this. It will be transformed into 4 dummy columns. Why 4? Because we have 4 cities. Now, same way, if you talk about here, because here, if you have here, let's say France, Spain, and Germany, it will be divided into 4 columns, into 3 columns like France, Spain, and Germany and stuff. So let's just run this and let's just see now what is the X. Now, if you see 1 for France, it can be, third column can be for Germany, second column can be for Spain, first column can be for France. This is just a little pre-processing that we can do. Okay, of course, we are not focusing much on pre-processing. So these are the only pre-processing that we will do for today's session. And now here comes the interesting part. Okay. Now, what we have to do here is that here we have to do a very important thing, that is train test split. Again, understand that trained test split is from the model selection from sklearn. So today we are going to use heavily sklearn because we are going to do the evaluation matrix. Okay. Now, here we are divided into 4. X-train, X-test, Y-train, Y-test. Like every data set, whenever we apply any kind of classification or regression algorithm, the same format like X-train, X-test, Y-train, Y-test. Okay. So now here comes the fun part. Now, what we are going to do is that we are going to import a very important package on the basis of which we are going to perform the evaluation matrix. And what package is that? That package is matrix. And matrix exists under which? It exists under sklearn as usual. So I'm just writing here from sklearn import matrix. Why? Because we need to perform some evaluation matrix here. And let me just run it. Okay. So till now, everything is fine. We are just importing. We have done little pre-processing and we have imported the data set, little pre-processing. We have divided our data set into training and test set, and we have called the matrix. Now, we will start with the logistic regression, and then we will apply naive-Bayes classifier. Of course, what's the difference between it? I will tell you as we move ahead. We will understand which provides good accuracy and which not. So first and foremost, for performing logistic regression, we need to import a package. And what is that package that we will be using? Of course, we have linear model from sklearn, and then we are going to import logistic regression. Now, we need logistic regression, and that is in the linear model. Okay, why linear model? Because logistic regression is a kind of a linear model that will perform the classification. Mind you guys, whenever we are using logistic regression, one of the most important advantages of logistic regression is that even if the data set are not balanced, logistic regression provide good accuracy than other classification model. And let's just run it. Now we have called the logistic regression, and now let's create an object of logistic regression. Let's say I'm saying rec, that's the object of logistic regression. So let me just run it over here. And now what's the next thing I'm going to do? I've created the object of logistic regression. Now, the very important step in all classification and regression algorithm is fitting the model to training set and the test set. So what are we going to do is that I'm going to write here, fit, we have X train, And we have Y train here. So we have X train, Y train, which we have already created here in the previous step. And now what are we going to do is that we are just fitting our regression model to X train and Y train. And so now let's just run it. Now we have fitted it. And now we have to predict. Now the model knows what is X train, what is Y train. Now what we have to do is that we have to predict. Now, how can we do that? We will just write here any variable name that you want, and I'm just writing predict X test. Now, mind you guys, we have two things here. One is here Y test and one is spread. Spread is from the predicted X test and we have Y test. And now we will compare. Y test is what we originally have and spread is nothing but something that we have generated through model. Now, what's the first thing that we are going to do? We have fitted the model, we have predicted, and now here comes the fun part. That's nothing but your confusion matrix. And now, what's basically a confusion matrix? Let's just see here. Okay, so we will just see what's basically a confusion matrix. Now, understand, whenever we are trying to say confusion matrix, it's basically a 2x2 rows and columns matrix. Now, what we are going to say, we are going to see how many observations we have, how many records we have. Out of that records, how much the model correctly predicted and how much the model incorrectly predicted. So if you see here, we have here the first column is reality. And then here we are saying yes, no. What does it mean? Do we have the yes observation? Are we predicting correctly? Is it yes or is it no? Means what? Now there is something known as true positive and true negative. True positive means what? We have the correct observation and we have correctly predicted. What is true negative? We do not have something and we correctly predicted that we don't have that. Now here is the thing that is troubling us. We have false positive and false negative. False positive is known as type 1 error and false negative is known as type 2 error. I will explain it with the help of one simple example. So now, as we were talking about the confusion matrix, we had something known as false positive, false negative. What is that? We will see with the help of an example. Now, this is a very simple example, which you can find it on the Wikipedia. Now, what is happening over here? Let's say we have something known as our main objective is to detect what are the cancer and a non-cancer. Okay, so we have observations and we want to find out whether the patient will have a cancer or not cancer. Okay, so now here, let's say just for simplicity's sake, we have 12 records. Okay, and out of the 12 records, 8 people actually have cancer and 4% do not have cancer. So there are 8 individuals with the cancer symptoms and they actually have the cancer, and 4 they do not have the cancer. So in reality, we have 12 records. Out of that, 8 with cancer and 4 with non-cancer. And now, what's the next thing? Our model predicted, this is what is our model. The green cells indicate the correct value. Now, here we have the cancer and non-cancer, the predicted one. Means what? Out of 8 people with the cancer, our model correctly predicted 6 cancer patients. Okay. Out of 4 non-cancer patients, our model correctly predicted that there are these are the non-cancer people. So the green indicates that that's a correct cell. Means 6 total people, 6 are cancer and they're correctly predicted. Total 4 who already have a cancer, who do not have a cancer, and it's correctly predicted that do not have a cancer. Now, here the one in the pink are the incorrect one, and that is known as false negative or false positive. Understand this cell, the green cells are known as true positive and true negative. Now, when we talk about Here, non-cancer cells. Let's say we have 2. What does 2 indicate? 2 indicate that 2 people have a cancer, 2 individuals are there who have a cancer, but the model predicted that they do not have a cancer. Understand how complex the situation may be in reality. There are 2 people, okay, they already have a cancer, but our model predicted that they do not have a cancer. Same goes, there is 1 person who do not have a cancer, but our model predicted that they have a cancer. So it's something like not in reality, it doesn't exist, but it is predicting something which is wrong. So what is the correct prediction is here in the green cells. And what is the incorrect prediction is in the pink cells. Okay. And now let's see how our model is providing, okay, for the predictions here. Yeah, I'm just going to my link here. Yeah. So now let's execute and see how can we find the confusion matrix. Understand the objective is to find out churn and non-churn. What is churn? A individual or a customer has left the bank, and non-churn is a customer has not left the bank. Okay, so now what we are going to do is that let's take a variable df confusion. And for confusion matrix, we have a very important package here, pandas. So what are we going to do is that let's just say pd.dataframe. What is data frame here? In the data frame, we will find out what is confusion matrix. Of course, we have already imported the package matrix, and this is one of the most important package which stores all the evaluation matrix. So what are we going to do? I'm going to write here matrix dot confusion matrix. Okay, because we want to predict what is the confusion matrix here. So now what are we going to do? What is y-test? Y-test is nothing but your actual record of the customers, they have left the bank or stayed the bank. This is the real records. Okay, and what is pred? Pred is the one that we have predicted. So let's just write here. Here we are just writing y-test and pred. But we have to print. Let's first execute and see what is the output, because we have to understand what it is going to give. So let me just print it, and then I will just tell you what are the changes we have to make. Now we cannot understand which is churn and which is non-churn. So what are we going to do is that we are going to provide a name to the column to understand which is the churn and which is the non-churn. Churn are the persons, those who have already left the bank, and non-churn are the persons, those who are not going to leave the bank. And then we are just writing here columns. Okay, so yeah. So, and then we will just execute. Okay, so I'm just writing here non-churn. So let's just execute and see. Now, what does it mean? This column, first column, is the actual results. And this over here, values, the churn and the non-churn, second and third column are nothing but the predicted one. 1553 are nothing but correctly predicted churn value. Means those customers who are going to leave the bank, they are being correctly predicted. And 25 are the non-churn. Means the correctly non-churn predicted customers. Those customers who are not going to leave the bank are being correctly predicted. Okay, and then this is 42 and 380, which are the incorrect predictions. So if you see here, there are 380 incorrect prediction. 380 customers are there who have not left the bank, but they have been predicted that they have left the bank. And here is 42, means the customers, those who have left the bank, but they have been predicted they have not left the bank. That's nothing but your confusion matrix here. And let's just understand what is classification report now. Now, what's classification report here? I'm just writing here matrix, and then I'm just writing here classification report. Of course, we are going to use y-test and pred. Now, here we have something like the evaluation of all the matrix. Now, what is that? Precision, recall, F1 score, and support. Now, what is that? We will just see here. What is basically a precision? Precision means what? Out of all the total correct predictions, how many are the yes prediction? Yes means in our case is have they left the bank? And what are the total? Like if in our case, we have 10,000 observations, out of 10,000 observations, how many have left the bank? Yes, in our case is nothing but how many are the churn rate? How many have left the bank? That is nothing but yes prediction, the correct prediction. Okay, that is nothing but your precision here. Then we have recall. Now, recall comes in two types. One is sensitivity and second is specificity. What is sensitivity? In sensitivity, how many are the total records and how much predicted yes? Yes, in our cases, how much have left the customers? What is the churn rate? How many customers have left the bank? And specificity is nothing but what is the total specificity is out of 10,000 records, how much is the non-churn? Means how many customers have not left the bank? So that's nothing but your recall. And if you see here in our output, we have something known as precision recall. Precision is out of 10,000 observation, how much have left the bank? 0 indicates the churn and 1 indicates the non-churn. Out of 10,000 records, 80% have left the bank and 37% have not left the bank. Same goes for recall and same goes for F1 score. Now understand, mind you guys, here when we talk about recall, there are two things in recall. One is yes and one is no. Yes is the churn rate, those who have left the bank, and no is non-churn rate, those who have not left the bank. Now, then we have something known as F1 score. Now, if you see here, we have something known as the F1 score, which is a simple mathematical formula here. That's precision into recall upon precision plus recall. This F1 score is very much useful when you have imbalanced data set. For regular data set, when that in reality, we will always get imbalanced data set. But if we find out something like balanced data set, we can use something like confusion matrix here. But for something which is an imbalanced data set, we will always use F1 score. And let's just now understand, we have to plot here the ROC curve. So we have classification report, which gives us precision, recall, F1 score, and support. So these are the way by which you can understand how good your model is predicting the records. And then we have here something known as ROC curve. Now, what is ROC curve? I will just show you with the help. When we will get the output, you will understand what I mean to say here. Let's just plot ROC curve here. I'm just writing here REG, that is our logistic regression object. And then we are writing here, predict. This is basically finding out, what is the accuracy score or, the graph. When you will see the output, you will understand what I mean to say here. We are just plotting the ROC curve. And then I'm just putting here two variables here. Okay. And then I'm just writing here matrix and ROC curve. What it is going to do, guys, it is just going to plot a very nice graph that will help us to understand what is basically the model it is doing. Okay, just a second. Yeah. Okay. Now, first, let me just print this model here. Okay, I will just tell you why it is. I will just write one more line here. That is nothing but matrix ROC dot AUC score. What is that? I will tell you in a quick second. And then we have Okay, now what does it do? As I told you, it is plotting a graph. How good the model is on this one, this line here. If this line is touching to the top left corner, means the model is doing very good. Accuracy value greater than 0.5 is always a good one. Okay, the more it is reaches to 1, it is a good model. The more it is less than 0.5 or it is coming nearer to 0, means the model is not working any good. Okay, so we have to understand this line, the blue line here. The more it is touching the top left corner, the more good our model is predicting. And now, this is what we have applied on the logistic regression. Now, we will quickly do the same thing on the bias, naive Bayes classifier. So now, what are we going to do is that here, we will do a very simple, same thing, whatever we have done, but here we are going to do on the naive Bayes. So what are we going to do is that I'm going to call the same thing quickly, sklearn.naive Bayes, and import multinomial NB. Why? Because for the naive Bayes, we will be using multinomial. There are various different naive Bayes. The one thing that differentiate logistic regression and naive Bayes is that logistic regression is more on a linear side when the data set is more linear and stuff. And mind you guys, when we talk about naive Bayes, it can work for non-linear one as well. But in naive Bayes, we have some disadvantages, like it cannot work for imbalance. It doesn't provide good accuracy for imbalanced data set. But if you're working with text data, like understanding the sentiment analysis or sentiment classification or spam or non-spam, at that time, naive Bayes provide a very good results. Now, let's create quickly an object of multinomial MB. And yeah. And then what are we going to do? We are going to quickly fit the model into X-train and Y-train. And what's the next thing that we will do? We will predict. And here I'm just writing predict, NB dot predict. And then I'm just writing here X test. Okay, understand that, guys, we already have Y test here, which is the original one, and the spread is nothing but one which we have to predict. Okay, now we have fitted the naive Bayes and we have predicted the naive Bayes. Now let's just perform the confusion matrix. Let's just find out the confusion matrix. So same thing I will quickly do, df confusion pd.data frame here. And then I'm going to write matrix.confusion matrix because we want to plot the confusion matrix, and then Y test, pred. And again, I have to provide an index because if I don't provide an index, it will not provide a very good value. Okay. Okay, it will be very difficult to understand which is the churn and which is the non-churn here. And let's just run this quickly. And then I'm just printing it. Now, if you see here, this model, how good it is not providing good value as logistic regression. Here, logistic regression was providing a value which is very good. Okay, it's providing 1553. The total 1,000 records, it is providing good out of 10,000 records. And if you see here, naive Bayes is not providing a good accuracy here, guys. So now what are we going to do? After confusion matrix, let's just print the classification report. Now, when I say here classification report, the same thing here, Y test and predictions. Right. Here, if you see, same thing. If you see here, it's 83 and 23. If you go into the naive, the logistic regression, it is 80 and 37. If you see here, we have 59 and 72 for logistic regression. And for naive Bayes here, we have 53 and 71. Somewhat same, but confusion matrix is telling us the actual results. So here we have 865 correct predictions out of 10,000. And here In the logistic regression, we have 153 correct predictions. So logistic regression is winning in this case. And then what's the next thing? We have provided the classification report. And now let's just print the same thing. That's nothing but your accuracy score. That's your graph here, ROC curve. Okay. So now what are we going to do here is that I'm just copy pasting it here quickly. And then here I'm just writing the naive-based model objective, that is NB. Let's just print it and see. Now, if you see here, it's a straight line. And if you see the accuracy is 55, whereas in the logistic regression, it is 67, way better than the naive base. Okay. So in our today's session, logistic regression wins because it is somewhat touching the top left corner. But when we talk about naive base, it is just a straight line. It is not performing good. Okay. So this is what we are using this graph for. This graph gives us a quick result, which is it a straight line or is it a curve? If it's a curve and if it is reaching the top left, means the model is doing good. But if it's a straight line and it is not trying to touch the top left, it is not a good one. Okay, so we have understood today what is confusion matrix, what is classification report. In classification report, we have precision, recall, F1 score support, and then we have found out this ROC curve. So that's it for the today's session. Any questions that you guys have? Guys, can you hear me? Yeah.
I was muted, sorry.
Yeah.
Thank you for the presentation. It was really interesting. Does anyone have a question? Feel free to pop it in the chat, or if you want to unmute yourself, that's fine as well.
Yeah, you can. And any questions are there, you can put it in the chat box. Yeah.
So,
yeah, so
I'll start with the question. So like you were showing the F1 score, the precision and recall and so on. Is there specific differences when you'd be favoring to look at one or the other? Or is it always the precision that is going to be your driver saying that one of the approach is better than the other?
Yeah, very good question. It is not like it depends on the models, on the data set, as well as is it imbalance or is it not imbalance? It will always depend on the type of the data set that we are using. Like for, as I told you, if we have an imbalanced data set, I will always go for F1 score. Okay. Now, like if we have here confusion matrix, let's say we have to find out 3 or more classes, like whether an image is a cat or a dog or something like more. It can be a squirrel or it can be an elephant. So depends on what type of data set, how much data set, how much classes we have to classify, what are the model. It depends on various things. Okay, for some cases, accuracy may give you a very good, but for other model, accuracy may not be the ideal solution. It depends. Okay. It always depends on the type of data set and the model. Yeah.
Okay. If no one else has a question, I have another one. If you could go back to the notebook.
Yeah.
There was some so if you go back to where the accuracy was printed, yeah, just there. So what is that macro average and weighted average?
Yeah, macro average and weighted average it depends. Like here we are tuning the parameters. Okay, so as the parameter, I have not went into details on tuning the parameters. If I would have went into the detail of tuning the parameters, we could have delved deeper with the macro average. Now here we are just dealing with the the simple ones. But as we have the parameters, like if we talk about SVM or decision tree, when we have the different parameters, the macro average, and the weighted average plays a very important role there.
Okay. Yeah. Very interesting. Okay. Thank you.
Yeah.
Okay, I have a question.
Yeah.
Okay, thanks for the presentation, though, the tutorial. I wanted to find out what's the difference between the logistic regression and the naive Bayes, right?
Yeah.
In this instance, the naive Bayes one.
Yeah, a very good question.
Yeah, like a one in quote. But I wanted to find out in which cases, in which scenarios would you say that use this type of regression over that one?
Yeah. Now understand the fact that naive Bayes has been worked very nicely for text like sentiment classification or spam or non-spam. Okay. But if the data set is a linear one, and if the data set is imbalanced, I will choose logistic regression because it's very easy to explain to the audience, like what are the different types of output. Naive Bayes is more about the probabilities, it's more about generating the probability. And in logistic regression, we are just understanding to which class it is belonging to. In naive Bayes, if you have some missing features, some missing variables, still it will provide a good accuracy output. In logistic regression, all the variables are mostly interdependent on each other. Yeah. Does it make sense? Yeah.
Thank you very much. Okay. Yeah, it does make sense.
Anybody, any questions? You can put it in the chat.
Sorry, just a follow-up question. So what you're saying is it depends, your data set will feed a lot into which kind of graph you're going to use at the end of the day.
Okay, can you just repeat the question now?
What I'm saying is your data set that will determine the type of graph.
Yeah.
Okay, thanks.
Now, I will first and foremost tell you how relevant, very good question, Begum. Thank you so much. Put it in the chat box. Now, first and foremost, the very important thing in that, in everyday life, we are going to work with the simple machine learning algorithm. We have deep learning and everything, but in everyday life, for every simple basic observations and basic generating the decision making, we are going to use the simple classification algorithms like logistic regression and the naive Bayes and SVM and the decision tree and everything. Now, why this evaluation matrix is helpful is because we want to understand which model provide the good accuracy. The more good accuracy providing model is, that model we will choose. And right now I have used just 10,000 records, but in reality, we use more records. We may have different data set, we may have a large data set or anything like that. So in that, if your model is working very good for a small data set, and this evaluation matrix will help us to understand which model will give us the good results, then we can implement that model onto a large data set, and it will definitely help us to provide a good decision making. Does it make sense? Yeah.
Thank you. Any other questions? Yeah, I think no more questions. So thank you very much for the presentation. It was very good, and thank you so much for bearing with us with all these technical difficulties. It really appreciate it, and then for everyone as well who put up with joining again and all that. Thanks a lot. So we will be putting this online as well. We'll share with you a YouTube channel where we have all of our tutorials. We'll also share a feedback form with you to let us know what else you'd like to hear about, what changes you'd like to see in these tutorials. And also, if you're interested in giving a tutorial yourself, there will be a form for that too. So we'll send all of these after the meetings ended in a few days. So thanks again for everyone, and thank you for the great presentation.
So much for having me today. Thank you. It was such a pleasure to give, and it was learning experience as well for me, to put up the presentation and stuff. Thank you so much for inviting me. Yeah.
Perfect.
Thanks, everyone. It was a fantastic session, Madhuri. Thank you so much.
Thank you so much.
Okay. Thanks, everyone.
Thank you,
Have a good
Andrea
evening.
and Madhuri. Bye.
Bye.